Hey there, so welcome to this video on sine law. We're reviewing our principles of sine law that we can use to find missing measures of sides and missing angles in all triangles, including right angle triangles. For this question, for these kinds of questions, we're going to use the rule above, which says A over sine A equals B over sine B. Now it doesn't matter what the letters are in a given triangle on an exam. It could be P over sine P, for example, but you do want to remember that small letters, like lowercase a and lowercase b, these represent sides, and that uppercase letters, like capital A and capital B here on the bottom, those represent angles. So you're always doing a side over its corresponding angle, and the sine of its corresponding angle, and another side over the sine of its angle. Now, when I say its angle, we're always talking about opposites, because in triangles, we should always remember that if this is angle A, straight across is side A. If this is angle B, that must mean this is side B. And similarly, if that's C, then this would be side C. So bear in mind that the side associated with an angle is opposite to that angle. And we can see that in this first review example below. It says find the unknown side. So I've drawn in the arrows already representing the relationship, and we can see, and there's no letters here, but we could put it, we could label them A, B, C if we wanted to. So I could see that I have, in this particular case, x over sine of 72 equals 6 over sine of 56. So I notice in this case it's a over sine A equals c over sine C, but again it could be any letters of the alphabet. Now to solve these, we have to use a cross-multiplying technique that your teacher has probably gone through with you. And it doesn't matter where the unknown thing is in a relationship of cross-multiplying two fractions. And these are two fractions. X over sine 72 is a fraction, and 6 over sine 56 is a fraction. But the method always involves crossing the two things you have. In other words, you have something, numbers that are across from each other, so 6 times sine of 72. And what I say is dividing then by the lonely one. So sine 56 is by itself because across from it is an unknown thing. So I'm going to do 6 times sine of 72 divided by the lonely one. And that'll give you my answer. So always use this technique when cross-multiplying. Cross the two things you have and divide by the lonely one. And I get for this that my answer for the unknown side is going to be 6.88. Now if you use this technique, then you don't end up rounding the sine of any angles. Trigonometry has huge magnification error. The more you round, the worse your answer is going to be, and that has huge implications for the long answer questions on the exam. So if you can do it all in one step, that's fantastic. In this next example, we have a question of finding the unknown side as well, but we're not given its opposite angle. It's missing. But as I've put down here, you can easily find the missing angle by remembering that all the angles in a triangle add up to 180 degrees. So if I do 180 minus the 55 we know, minus the 42 degrees that we also know, we'd get 83 degrees here in this corner. Now we're able to solve our triangle. So again, you always take opposites. X goes over sine 83, and 5 over sine of 42. And again, our unknown is on the top. I'm going to cross multiply these two guys because I have them. So 5 times sine of 83 divided by sine 42 will give me my unknown. And it should be 7.42 approximately. And we'll just say 7.42 units. Okay, well, what happens if you're missing an angle? It's essentially the same process. We're still using our opposites, but the thing that's unknown is actually an angle of a triangle. So let's set up the same relationship that we were just doing. If I have 8 over sine of 76, because that relationship's quite clear, that's going to equal 7 over sine of x. Now, don't just put over x. I've seen that many times on test. Remember that you have an operation going on here in the denominator. We're taking the sine of an angle. That's why it's called sine law. So once again, I'm going to multiply the two things I have and divide by the lonely one, which is the 8. So sine of 76. Now please put this in brackets in your calculator, or else you'll end up with sine of 76 times 7, which will give you an error note. Okay, times 7 divided by 8. And you should get a decimal answer. I get 0.84 when I do this one. And I'm going to leave it on my calculator screen. Even though I'm writing it here for you, please leave it on your calculator screen. Don't clear it. Okay? Now, the answer's, the angle here is probably not 0.84. I mean, we're looking at 76 over, down here. How can we have a decimal? Well, that's because this is the sine of the angle. This is not the actual angle. We solved for the sine of x. So what we want to do is take the inverse sine of that answer. And again, I'm going to tell you how to do that on your calculator without retyping in all the decimal places. But what you should use on your calculator is either second function, like some calculators have second function, or inverse, like, to get the little numbers that are subscripted on the buttons on your calculator. So second function, and then sine. So that'll get you your sine -1. And then your next button that I would use if you have a calculator like a Casio would be the button that says ANS. And ANS means your last answer. It keeps all those decimal places in there. So I'm going to do that now. Shift, on my calculator it says shift instead of second function. Shift sine, my last answer, and I get an answer of 58.1 degrees. And that seems a little more appropriate. (104 degrees). So if you got a number wildly different than this, that means you're rounding somewhere along the way. So just be careful around that. Now this last example is quite important because this is an exam favorite, big time. They love this magical word right here that says obtuse. Now, if you remember from previous years of mathematics, obtuse means an angle that's larger than 90 degrees. And you can see that here in for angle C. How do we solve for an obtuse angle? Well, it's the same way that we did the example above, but with one little extra step, and I'll show you as we get there. So let's set up our sine law. I notice that 50 degrees is opposite of 8 centimeters. And I notice that 10 centimeters is opposite our unknown angle. And that's the Greek letter theta. You can use x for an angle, theta. You can use pretty much anything you want. So 8 over sine of 50 equals 10 over sine of theta, or sine of c if it makes you happy. If I cross multiply the two things I have and divide by the lonely one, I end up with sine of theta being 10 times sine 50 divided by 8 is 0.95, 0.9575, etc. And I'll just leave that on my screen and do what we did above with the second function, sine button a and s, is 73.24. Now, this is a bit of a problem. Not the same as the picture, is it? Well, the problem is that this is an acute angle. It's not bigger than 90 degrees. So when a question says find the measure of an obtuse angle, you have to take your answer and subtract it from 180 degrees. Now, I can't emphasize enough how key this question is. It's shown up consistently 6 times out of the last 8 government exams. So please make sure that you have a version of this on your memory aid. It's most often, a multiple choice question. And I get 106.75 degrees. And that's your answer. So the key word here is obtuse, and that makes a little more sense for angle C, which is clearly larger than 90 degrees. Make sure that one goes on your memory aid.